Canadian oil production. Oil is produced, extracted, using different methods depending on geology and location. After recovering the oil, it is sent to refineries to create refined products we use every day, such as gasoline. The first efforts to tap the oil sands resource began in the mid-20th century using hot water to separate bitumen from sand. Since then the process has evolved into the sophisticated methods we use to extract oil today. What is oil? Oil is a black, brownish, or amber liquid. A complex mix of hydrocarbons including carbon, hydrogen, sulfur, nitrogen, oxygen, and metals. Oil formed millions of years ago from animal and plant remains deposited in sand and silt, and pressurized by layers of sedimentary rock. Oil is classified as light, medium, heavy or extra heavy. Light and medium oil can flow naturally to the Earth's surface and is generally extracted from the ground using vertical drilling and pumping. This includes Canada's offshore oil. Some light oil is trapped in tight, non-porous, rock formations, usually shale. This light tight oil can be recovered using horizontal drilling and hydraulic fracturing. Heavy oil has a thick consistency that does not flow easily, often requiring advanced technology to extract. The Canadian regions with tight oil reservoirs include the Bakken, which is found primarily in Saskatchewan, several fields in Alberta including Cardium and Viking, and the Montney and Duvernay in Alberta and BC. How is oil extracted? Oil is recovered, extracted, using different methods, mostly depending on geology. Conventional oil. Conventional oil is extracted from underground reservoirs using traditional drilling and pumping methods. Conventional oil is a liquid at atmospheric temperature and pressure, so it can flow through a wellbore and a pipeline, unlike bitumen, oil sands oil, which is too thick to flow without being heated or diluted. It's easier and less expensive to recover conventional oil and it requires less processing after extraction. Conventional oil development is both land-based and offshore. Unconventional oil. Unconventional oil cannot be recovered using conventional drilling and pumping methods. Advanced extraction techniques, such as oil sands mining and in-situ development, are used to recover heavier oil that does not flow on its own. Oil found in geological formations that make it more difficult to extract, such as light tight oil, LTO, is also called unconventional oil because non-traditional techniques are needed to extract the oil from the underground reservoir. Light tight oil is found throughout much of the Western Canadian Sedimentary Basin, WCSB, plus in central and eastern Canada. LTO is found deep below the Earth's surface, primarily within low permeability rock formations including shale, sandstone, and mudstone reservoirs. This kind of oil extraction uses horizontal drilling and hydraulic fracturing. Surface mining. Oil recovery in the oil sands uses two main methods, mining or in situ, depending on how deep the oil sands deposits are. Surface mining is used when oil sands deposits lie within 70 meters, 200 feet, of the Earth's surface. 20% of oil sands reserves are close enough to the surface to be mined. Large shovels scoop oil sand into haul trucks that transport it to crushers where large clumps are broken down. The oil sand is then mixed with hot water and pumped by pipeline to a plant called an upgrader, where the bitumen, oil, is separated from the other components such as sand, clay, and water. Oil sands tailings. Tailings ponds are common in all types of surface mining around the world. In the oil sands, tailings, consisting of water, sand, clay, and trace amounts of oil, are pumped to ponds where the sand and clay gradually settle to the bottom. Water near the top is reused in the mining and bitumen separation process. Once a tailings pond is no longer needed, it is reclaimed. Oil sands companies that have mining operations are researching many techniques to solidify the tailings faster so the ponds can be dried out, resurfaced with soil, and planted with local tree and shrub species. In situ recovery. Deeper bitumen must be recovered using in situ technology. In situ means in place, because bitumen is separated from the sand below ground, right in the deposit itself. This is accomplished by heating the bitumen so it becomes fluid enough that it can be pumped to the surface. There are several ways to heat bitumen below ground. Both of the commonly used methods, SAGD and CSS, use large volumes of water and burn natural gas to create steam that is injected into the oil sands deposit. New research is leading to technologies that reduce or eliminate the need for water and natural gas. Steam-assisted gravity drainage, SAGD. Currently, most in-situ operations use steam-assisted gravity drainage, SAGD, which uses well pairs, two wells, an injection well and a production well, drilled one above the other, to recover bitumen. The injection well is drilled vertically into the deposit, then turned 90 degrees and drilled horizontally. A second well, known as the production well, is drilled deeper than the first, paralleling the horizontal portion of the first well. Steam is injected into the deposit through the upper well. Heated bitumen begins to move by gravity down toward the second well. Pumps in the second well draw the bitumen into the well and up to the surface. Multiple wells, sometimes more than 20, can be drilled from a single surface location, further reducing surface disturbance. Cyclic steam. This method pumps steam down a vertical well to soak or liquefy the bitumen, which is then pumped to the surface through the same well. This technique is repeated until most of the oil is removed. Offshore oil extraction. Extracting oil from Canada's offshore is a unique process compared to onshore oil extraction. Initially, companies may begin their exploration process by reviewing existing geological and geophysical data to learn more about potential reservoirs. Next, seismic surveys are completed to map geological structures under the seabed. If an analysis of seismic data shows a geological structure that could contain oil and natural gas resources, a company may decide to drill an exploration well. As precise information is needed before investing in drilling an exploratory well given because of the high cost of drilling in the offshore. Before drilling and offshore oil extraction can begin, companies must apply for the appropriate approvals from the relevant regulatory body in Atlantic Canada. Offshore development. Should a company decide that it wants to proceed to offshore oil and natural gas production, the next step is development. The offshore development phase can take 5 to 10 years, depending on the size of the project. During the development phase, the company develops a series of plans which outline exactly how it will produce the oil and natural gas in a particular reservoir, the environmental protection measures that will be put in place to minimize any environmental impact, the safety measures that will be used on the project, and the benefits of the project to the relevant communities and province as a whole, including employment, revenues, contracts, etc. Offshore oil production. Finally, production commences on the offshore oil project. Producing oil and natural gas offshore is a complex process due to the challenges of operating in a remote and sometimes harsh environment. Production facilities are built to withstand the offshore environment and its challenges, including the potential for sea ice and icebergs in some areas. Upgrading and refining. Some heavy oil, and about half the bitumen produced from the oil sands, is upgraded to create synthetic crude oil. Synthetic oil is usually low in sulfur and contains no residue, very heavy components. Upgrading can occur at or near the producing area. Upgrading is usually a two-stage process. Coking or hydrocracking, used to break up the molecules. Coking removes the carbon, while hydrocracking adds hydrogen. Hydrotreating, used to stabilize the oil and remove impurities such as sulfur. Upgrading uses temperature, pressure, and chemical catalysts to crack bitumen's big, complex molecules into smaller ones. Adding hydrogen or removing carbon from the oil creates hydrocarbon molecules like those in light oil. Upgraded synthetic oil is then refined, just like conventional crude oil, to make gasoline, diesel, jet fuel, and heating oil. More than 30% of Canadian oil production is refined in Canada, the rest is exported to refineries in the US. Canada is seeking new overseas markets for our oil, but more pipeline capacity is needed to make this a reality.